Evaluate the integral. Answer exactly. Here we have a definite integral from 1 to 2 root 3 over 3 of dx over the absolute value of x times the square root of x squared minus 1. You need to recognize this as a special type of integral. It has the square root in the denominator, so that right away is going to indicate to you that this is most likely going to be one of your arc-trig functions. And those are just formulas that you have to memorize at this point. And the formulas that we would be working with, the base formulas for sine, tangent, and secant, if you look at those formulas, the one that fits this particular situation the best is going to be the third one here, which is arcsecant, because I have this multiplier of the function u on the outside of my square root in the denominator. But also the order of the terms inside the denominator. It's the function minus the constant, and this is a function minus a constant. So this is what I'm looking for. All right, now to work this through, what I need to do is first off identify what I'm going to use for u and a. So the function u is the square root of the term that appears first, the function term. So the square root of x squared is x. Square root of this constant over here, a squared, this is just going to be the square root of 1, which is 1. Now we have to also make sure that the rest of the stuff fits. So we have to have just the function u on the outside here. So this is just the function u. It does say the absolute value of u. It doesn't really matter if you have the absolute value at this point or if you have it over here at this point. I think the reason that they decided to put it here is that it's easier to type in your answer if you don't have to worry about the absolute value in the solution. Also, we need this du to match up. So the du is just dx, and that matches up what's in the numerator, so that's good. Now, integrating, we're really just following this formula. It's 1 over a, and a is 1, so 1 over 1 is just 1. I'm just going to put that in for emphasis. And then we have arcsecant of u over a. So u is x, and over 1, that's just x. And then we're integrating from 1 to 2 root 3 over 3. So what I need now is to evaluate this using the Fundamental Theorem, which says to evaluate the arcsecant at the upper end point, 2 root 3 over 3, minus the arcsecant evaluated at the lower end point of 1. So to evaluate arcsecant, first thing is, in the calculator, you don't have an arcsecant function, but you do have arccosine. And the relationship between arcsecant and arccosine is the same as the relationship between between secant and cosine. They're just inverses of one another, so that's no big deal. One thing that you want to pay attention to is that when you do an arc-trig function of any sort, the result of that arc-trig function is going to be an angle measure. So it's going to be easier to identify what angle measure it is if you're in degree mode, and then your final answer needs to be converted to radians. So we use degree mode temporarily to just identify the angle measure, and then we convert them. Now, let me show you something about these arc-trig functions, just so you're convinced as to how this works. All right, so I have the arcsecant of 2 root 3 over 3 is going to be equal to some angle measure theta. Now, if I take the secant of both sides of this equation, and I guess that's going to be hard to express, let me write it, then secant theta. The secant of arcsecant cancels each other out. So what we're saying is we're looking for the angle measure, whose secant is 2 root 3 over 3. If I want to convert this to cosine, here's what I would do. So this would be 1 over cosine is equal to secant. Okay. And then if I invert both sides, I would have cosine of theta is 3 over 2 root 3. So effectively, I have inverted the angle measure, and I plug it into arc cosine, because now I can take the arc cosine of both sides, and that would be arc cosine of 3 over 2 root 3, and it's not going to matter one bit to the calculator that this isn't reduced. Certainly you could make it root 3 over 2 if you wanted, because 3 divided by root 3 is just root 3. And in fact, that actually does look simpler to type in, so I'll just do that. So make it root 3 over 2. So when I type this into the calculator, effectively all I need to do is arc cosine and invert this value here. So since I know that inversion, I can go ahead and just put root 3 over 2. Or an alternative is I could have just done arc cosine of 2 square root of 3 divided by 3, and that's in a set of parentheses. Now this is going to look terrible, but this raising to a -1 power inverts it, so you're doing arc cosine of the inversion angle, which is effectively ArcSecant. So either way you want to handle that, that's fine. It makes no difference to me. The result here is 30, and if you want to convert that into radians, just divide it by 180 and make it a reduced fraction. But just oh, I didn't mean to have the, let me try that again. So 30 divided by 180, I had this raised to the -1 power there, and convert that to a fraction. So 1/6, just remember that pi is involved in this operation as well, so it's actually pi over 6. So, but if you throw pi in there, the fraction function won't be able to reduce it. All right, then arcsecant of 1. So that's a bit easier. Arc cosine, and 1, the inverse of 1 is just 1, so that's okay. Just put in 1. We get 0. So our final answer here is pi over 6.